So now that you've learned the process to be able to classify quadrilaterals, we're going to actually do some examples now. So in these examples, they're going to either give you some coordinates of a figure, and so in this case it says that it's a quadrilateral, or they might have it graphed already on your graph, okay? And so in this problem, it says you've got quadrilateral A, B, C, D, and these are the vertices of that quadrilateral. And so the question that they'll ask is you have to classify the quadrilateral. So what they're asking you to do is tell what type of quadrilateral it is, okay? So the first thing is you're going to plot the points. So let's graph the points. So we got 4, 7, 1, 2, 3, 4, 2, 3, 4, 5, 6, 7. So that's A. Then we have non-7. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 7. 1, 2, 6, 7. Okay, and then we have, and I'm going to wait to label them in just a minute because I don't know where the rest of it's going to be. So we got 6, 3, so 5, 6, and then 1, 2, 3. And then we have 1, 3, so 1, 1, 2, 3. All right, so now I can label them. So we got A, this one was B, this one was C, and this one was D. And then I'm going to connect them. And now, when they give you coordinates and you're able to actually look at the figure, you can kind of look at the figure to know the direction to head. Compared to the other problems, we didn't really know what it was going to look like until we actually started looking at the slopes and the lengths. But when you're actually given the real picture of it, you can kind of go off of it. So, like for instance, I know that this one is definitely not going to be a square because if I look at the angles, they aren't 90 degrees. And so for the same reason, it's not going to be a rectangle. So now we've got to figure out, well, then what figure is it? What do we call it? Because we want to give it the most specific name. So the process that you do this is you kind of do just like what you had been given information-wise in the other problems. So you're going to find the lengths of each of the sides, and then you're going to find the slopes, and you're going to look at those to tell you what type of figure it is, okay? So this is where it brings in the distance formula and the slope formula, all right? So if I had to find the length of the side AB, well, notice that one's an easy one because it's lined up with the actual grid. So you can just count. So 1, 2, 3, 4, 5. That one has a length of 5. The side BC, that one's not as easy. And so because it's not lined up with your grid. So that's where you have to either do the distance formula. So you use B as one of your points and C as the other one. And you find the length from B to C using the distance formula, or you can do the Pythagorean theorem. And using the Pythagorean theorem would be better or easier for these since it's on a graph. So remember Pythagorean theorem, you kind of make your little right triangle, and then you count the lengths of the sides of your right triangle, or the legs, and then you plug it in Pythagorean theorem. So in this triangle, this side right here has a length of 3. That side, 1, 2, 3, 4, has a length of 4. And so those are your legs, and what you're looking for is the length of this side right here, which is your hypotenuse. So you go to the side, plug it in. Remember, Pythagorean theorem is a squared plus b squared equals c squared. So it'd be 3 squared plus 4 squared equals your c squared. This is your c. And then you just simplify. So 3 squared is 9, plus 4 squared is 16. And bring down my equals c squared. Then I combine them. So 9 plus 16 gives me 25. And then to get rid of the square, you square root. And so the length of that side would be 5. So BC has a length of 5. Notice those sides have the same length. I know it's kind of strange, but they have the same length. So now we know that. So now let's keep going. So CD, that's another one that's easy to count. So 1, 2, 3, 4, 5. That one has a length of 5. And then DA, that's another one that's at a diagonal, so I'm going to have to do Pythagorean theorem. So let's see if I make my little right triangle. to go from one point to the other. This one is 1, 2, 3, 4. That one is 1, 2, 3. And notice those have the same exact lengths of the sides as this one did. So if I plug it in the Pythagorean theorem, it's going to look exactly the same. So that one will end up having the same length. So if you kind of pay attention, you can save yourself some time and not have to redo a problem that you've kind of already done. All right. So if I'm looking at this, the first thing that I notice is all the sides have the same length, because remember, distance is the same thing as length. And so if you kind of look at your little shortcuts that we had done, if they have the same length, then that kind of points to maybe it's a rhombus, okay? And so maybe we're looking at a rhombus. Well, to be a rhombus, the opposite sides have to be parallel, because remember, a rhombus is a type of parallelogram. So to know if the opposite sides are parallel, we can check the slope, okay? So we know first that all the sides are equal. Okay. So now check the slope, and we can just double check and make sure that the opposite sides would be parallel. So slope, remember, is your rise over your run. So if we're going to find the slope of each line, you do rise over run, okay? So AB, well, AB is just a flat line. So if it's just a flat line, remember the slope is 0. So that one would be 0. Same reason, CD, this one right here, would also have a slope of 0. So those are easy. But then these other ones had a slope that won't be 0. So if I have to find the slope of BC, you start at one of your points and you do the rise over run. Okay, so rise over run. Okay, so if I start, for instance, at B and I'm trying to get to C, I have to go down. So 1, 2, 3, 4. I go down 4. So that would be -4 for the rise part, because I have to go down. And then I have to go left 3. So 1, 2, 3. If I go left, that actually is a -3. Okay, so -4 over -3 ends up being 4 over 3. So that's the slope of this side. And now we do the same thing for that last side, DA. All right, so DA, I'm going to start at a point and go to the other one. So if I start at D, I have to go up. So 1, 2, 3, 4. And then I go to the right, 1, 2, 3. And so up 4 is +4 over, I have to go right 3. So that would be over A3. And so look at your opposite sides. Do they have the same slope? So these two have a slope of 0. Those two both have a slope of 4/3. So your opposite sides have the same slope, which means that the opposite sides are parallel. So this is a parallelogram, but it's more specifically a rhombus, because a rhombus is a parallelogram that has equal sides. So if you had to classify this, you would give it the more specific name. So the last step in this is you classify your quadrilateral. So that would be a rhombus. Okay, so let's do one more, and then we'll work with triangles after this. All right, so what if we had a quadrilateral that had these as the coordinates? So you start by graphing it. So we got -2, 5. So -2, 1, 2, 3, 4, 5. Then we have 1, 8. So 1, 1, 2, 3, 4, 5, 6, 7, 8. And then we have 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. And then we have 1, 2. All right. So now let's go back and label them. So that was A. This was B. And if you want to actually write the coordinates with them, that wouldn't be a bad idea either. And then we have D. All right, so let's connect them. So first off, you need to kind of look at the figure to kind of guide you with what it looks like, and then you have to kind of prove it in a way, because looks can be deceiving, especially since we're drawing these freehand. Okay, so first thing you want to do is find the length of each side. So that's where you use Pythagorean theorem. So like if I have to find the length of this side, It's at a diagonal, so I'm going to make my little right triangle here, and I'm going to find the length of each of these and do Pythagorean theorem. So we got 1, 2, 3. That's the length of that side. 1, 2, 3. That's that one. And we're going to plug it in Pythagorean theorem to find this length right here. So it would be, and I just go to this side, it'd be 3 squared plus 3 squared equals c squared. So then 3 squared is 9 plus 9 equals c squared. Then you add them, so it'd be 18. And then from there, you square root. Now, you could potentially leave that as the square root of 18, since we're just comparing the lengths, kind of like in those examples on the other video. Or if you wanted to type that in and see it as a decimal, because you don't like looking at it that way, you can do that too, okay? So we're going to go through, so that's the length of AB, okay? So that's how long that side is. We're going to go through and find the length of all the other ones, okay? So BC, it's at a diagonal, so I'm going to do my little right triangle, okay, and I'm going to erase this one because I guess we're done with it. And so if I draw my right triangle here, I've got 1, 2, 3. That one's 1, 2, 3. So notice that'll actually be the same work. So this one ends up being the square root of 18, or 4.24 as well. Okay, so keep going. So if we have to find the length of CD. All right, well, it's at a diagonal, so I'm going to do my little right triangle again. So that'd be 1, 2, 3. 1, 2, 3. Notice it's the same thing. So if you're going to if you have the same lengths of the sides of your right triangle when you make it, it's going to be the same work. And so you can actually save yourself time because it'll be the same length, okay? So then DA, let's see if it ends up being the same. So that, if I make my right triangle, it'd be 1, 2, 3, 1, 2, 3. So it'll give me the same lengths. So that one would also be square root of 18, okay? So notice all of the sides have the same length. And so you could actually mark that in your picture if you wanted to. By putting little tick marks. So you know right now that it is going to be a quadrilateral that has 4 equal sides. So that's going to kind of point you in one direction. So now let's check the slopes. So to find the slope, remember that's rise over run. So like from A to B, I have to go up 3. So that's the rise part. So up 3 is a positive 3. And then I have to go right 3. So that would be a positive 3. So the slope would be 1. Okay. BC. To go from B to C, I have to go down 3 and then right 3. So down 3 is actually a negative 3, and then right 3 is a positive 3. So that would end up being a negative 1. Okay. CD, I have to go down 3, which is a negative 3. And then I have to go left 3. So that's a negative 3. Going left is negative. And so negative 3 over negative 3 is 1. And then DA, last one. You can go from any point to the other one. So I'm going to actually start at A. So I have to go down 3 and then right 3. So down 3 is a negative 3. Right 3 is a positive 3. So that ends up being negative 1. So if we look at the slopes, remember the slopes tell us if the lines are parallel, or and it also tells us if we're going to have right angles or if they're going to be perpendicular to each other. So first look at the opposite sides. So AB and CD are opposite, and then BC and AD are opposite. So if I look at AB and CD, they have the same slope. If I look at BC and DA, they have the same slope. So I know, number one, that opposite sides are parallel. So if opposite sides are parallel, that means it's at least a parallelogram. But then also, to see if they're perpendicular, you look at the sides that are beside each other and see if they have negative reciprocal slopes. So like for instance, AB and BC are beside each other. So if I look at AB and BC, remember you take this, so this would be like a 1 over 1. So if I flip it, it would still be 1 over 1. But then if you change the sign, it would be a negative 1 over 1, which is negative 1. So notice they are what are called negative reciprocals to each other. So, and that actually happens for all the sides that are beside each other. So if that happens, then that means you have 90-degree angles in your picture. So because it's true with all of them, we not only have congruent sides and 90-degree angles and parallel lines. So what does that mean? Well, which figure has 90-degree angles and congruent sides and parallel side or opposite sides that are parallel? Well, that would be a square. So this one is a square. Okay.